All right, so now that you've had a chance to do the exploration and experience the six gas laws in a qualitative way, we're going to take a look at those six gas laws quantitatively, come up with some equations that we can use to represent those relationships. So the way that we're going to do that is to divide the two types of relationships into those that are direct and then those that are inverse. So if you go back and look at everything, the direct relationships were pressure versus temperature and pressure versus moles, as well as volume versus temperature and volume versus moles. But that leaves us with two inverse relationships, pressure versus volume and temperature versus moles, or moles versus temperature. So now let's focus on just the direct relationships. We're going to come up with a mathematical equation to show that relationship. So what happens mathematically if I increase one value? What happens to the other one? How can I use that as a means of setting up an equation? So let's deal with kind of set one and set two variables. So P1 and T1 along with P2 and T2. So this is like my before set, and then this is the after set. Similar to what we did when we talked about concentration. So let's keep things simple. Let's say that my starting units are 1 and 1 for both temperature and pressure. Well, what's going to happen to temperature if pressure doubles? Since a direct relationship, as one goes up, the other goes up. So if pressure doubles, what happens to temperature? Temperature also needs to double. So that gives us some numbers to work with. So mathematically now, how can we show that relationship? One set of variables compared to the second set of variables. So if you trial and error the possible choices, you will eventually come up with the fact that if we take pressure and divided it by temperature, that is going to equal the second set also divided by each other. And if you think about it, 1 divided by 1, we can put the variables in there, is equal to 2 divided by 2. And that's a true relationship. So this idea of dividing whenever you have a direct relationship is always going to be a true representation. So we can have 3 more equations to represent the pressure versus moles, the volume versus temperature, and the volume versus moles, set up the exact same way as P over T. So P over N is equal to P over N, volume over temperature is equal to volume over temperature, and volume over moles is equal to volume over moles. So in one little thought process, we have come up with 4 of the 6 equations for the gas laws. We're going to do the same thing with the inverse relationships, pressure versus volume and moles versus temperature. So once again, let's do the befores and afters. So start out simple, leave pressure and volume both a value of 1 to start with. But now that it is an inverse relationship, if I double the pressure, what has to happen to the volume? Since it's inverse, volume has to go down by the same factor, so volume is going to decrease by a factor of 2. So now mathematically, we're in a different situation. If I divide these 2 variables by each other, I'm not going to get the first set equaling the second set. So what equation am I going to need to use in order to show an inverse relationship? Well, you've probably figured out that in order to show an inverse relationship, just like concentration and volume for the dilution equation, you've got to multiply the variables because one goes up, the other goes down, but you maintain a constant value, the product. So here's what I would do, and again, if you take a look, 1 times 1 is definitely equal to 2 times a half, so mathematically that works. So now we've got the relationship for pressure and volume, and also, because it is another inverse relationship, we have the moles versus temperature. So we have now managed to get all 6 variables, or all 6 relationships with the 4 variables into mathematical equations. Our next step is going to be taking those ideas and combining them into what we're going to call the combined gas law. But that is part 2 of the video, so please do watch that next before you try any problem sets.